Hello my dears, and another beautiful question from by using this SVC, by using SVC is nothing but see, a transmission line has equal voltages at two ends maintained constant by two sources. Actually a transmission line consists of two sources. What was the purpose of that? In order to maintain the voltage profile, a constant one, a beautiful voltage profile we have to maintain. Suppose we are there only one source, then the other source will be a dip in voltage will happen there. So in order to avoid that, we are using two sources, but still the two sources will be super voltages, equal voltages. Then what about the middle again? See, a third source is to be provided to maintain constant voltage. A third source is also there, which we are providing in order to maintain the voltage profile or constant voltage equal to sending end voltage at either the midpoint of the transmission line or at 75% of the distance from the sending end. The maximum power transfer capabilities of the transmission line in the original case and the other two cases respectively will be in the ratio. See, the question may be, while reading the question, you may feel it is very difficult to solve, but the answer is very simple, right? See, a transmission line has an equal voltages at two ends maintained constant by two sources. So, without you see, this is the original line, right? A third source is to be provided to maintain the constant voltage either at the midpoint or the 75% from sending end. The maximum power transfer capacity of the transmission line in the original case. So, original case is nothing but, my dear, a transmission line has equal voltage at two ends maintained constant by two sources. That is the original case. So, we'll discuss first one, original case, or simply case one. No? Okay, original case also you can take original case. So in original case there are only two sources. Okay, two sources, S1 or S2 something. So okay, and maintained constant by two sources, and it having a transmission line of reactance, what, my dear, X. It's understood now. So P max or maximum power transfer capacity will be EV by X. EV by X. Next one, another case, case 1. Case 1, what we are doing in case 1, we have to introduce another source here, the middle of the transmission line. First one is it is in middle of the transmission line. Another source means it is nothing but, my dear, static var compensator. Another source means static var compensator. So what happens then? The transmission line reactance will be X by 2 here, and here also it will become X by 2. So now the P max now will be what? Now the P max will be dash. P max will be what? EV divided by X by 2. Simply 2 EV divided by X. Is it clear? So initially the original case it is EV by X. Now it will become EV by X. Is that over? No. One more case is given. Suppose the SVC is given at either the midpoint of the transmission line or at a 75% distance from the sending end. So there is another possibility is also there, my dear. So this is our two transmission, sources. We can place our SVC here also. The question is given as the SVC is placed at 3 by 4 of the X. And it will be 1 by 4 into X. 75% distance from the sending end means this is the sending end voltage. So from this the transmission line length will become, or the SVC is placed at 3 by 4 of the length. 75% of the length means 3 by 4 of the length. So 3 by 4 into X, and other one will be what? Simply 1 by 4 into X. Now the P max will be what? P max will be nothing but, my dear, EV divided by 3 by 4 into X, or I can write 4 by 3 into EV by X. Another possibility is also there here itself. Here itself another possibility of also there, my dear. If you are taking from here to here, they are specifically given it is the sending end voltage now. From sending end it is given now. So no need to use this another term, that is EV by 1 by 4 X also you can take. But they are specifically given from sending end. It is given now. So, but maximum power transfer is there or not, we have to check now. So let's see. Suppose from here to here if I am looking, then what will be? See, The SVC is placed at 75% sending end voltage, okay. But in the other sending end, these two are sending now. These two are sending, right? So this is also, you can act, these two are sources. So you can place 3/4 extras like this, or from here also you can take. So it will be EV divided by x/4 also you can say. It will be 4 into EV by x. So by comparing these two, only these two, you have to note one important thing, my dear. If the power handling capacity is 4 times as that of the original case, that is a 4 EV by max min B, the system will have that much power handling capacity, means the system will that much tendency to be unstable. That much power handling capacity will not be carried by the conductors. We already designed some conductors now. The transmission line is designed by some conductor by specification now, some specification now. If the 4 times power handling capacity will not be carried by this transmission line, so always prefer, if the maximum power transmission capability, lower values you have to choose always. That means we don't want to choose this 4 into EV by mass now itself. Now itself you don't want to do that. So this can be avoidable because it's maximum 4 times power handling capacity is there. So that is not at all a good thing. So we have to finally find, we have to only take these values, my dear. So first one, second one, this one. So this is the original case, this is the midpoint case, and this is the 3/4 like the case. So what will be the ratio now? What will be the ratio now? You can take the ratio as, so the ratio equal to 1 is to 2 is to what? 4/3. Is it clear? Or simply 1 is to 2 is to 1 by 0.75. That also you can take. 4/3 means 1 by 3/4 now. So it is 1 by 0.75. Anything, anyway you can take the answer. So this is the final answer for the question. Thank you.